Hey everyone, and welcome back. We're going to do the last part of the chapter 3 lecture, which deals with making decisions. And so last chapter we had about 30 slides dealing with loops, a lot of loops and arrays. And so it was quite a bit of information in the last PowerPoint. So definitely go back and review that and watch that PowerPoint before you watch this one. Um, But we're going to start with making decisions, and I have an empty page here, and I just wanted to put this down for theory because I kind of skipped something in that last PowerPoint, and I think I did an okay job of answering why loops. You know, the question got asked, okay, in the real world, why would we have loops? And I think I answered that decently enough, but I thought about it a little bit more. And I wanted to provide a slightly different answer because loops can make our programs seem powerful. And what I mean by that is what I explained last time, in that you can write maybe 5 lines of code, that those 5 lines of code do a whole lot, right? They produce a lot of results by writing 5 lines of code. So from an end user's point of view, there's a lot that's happening on the program or in the JavaScript. There's a lot that's occurring, but from a programmer standpoint, we only had to write 5 lines of code, right? So a loop to a user makes the application powerful, makes it do a lot. An example of that, and someone said, well, give me a real world example. And I thought of another example that I'd like to share. And that example could be read information out of a database. And while there's more information to read, continue to display that information in a certain format. But notice I use the keyword while, like a while loop. While there's more data in the parentheses, display the data in the loop body. Okay? Now there could be 10 terabytes of information inside of this database. But with one while loop, you could say while there's more data, display the data on the page. And so within one while loop, you can display a whole lot of information. And there might be calculations and other advanced things in there, right? But that's kind of the general purpose of a loop, is to make your program seem powerful, write a little bit of code that does a whole lot. Well, then I thought I'd answer why conditional statements? And that's what we're going to talk about next. Matter of fact, on the PowerPoint, they call it making decisions. And, you know, why conditional statements? I would say because conditional statements make our programs seem smart. Okay? Whereas loops make your programs powerful, conditional statements make them, well, I wouldn't say seem smart, make them smart. Conditional statements are what allow an exciting new piece of technology that came out last week or 2 weeks ago. And this would be really cool 10 years from now when we're talking about this and reflecting about it. So here we are. It is November 7th, 2016. And a couple of weeks ago, for the first time ever, a semi-truck drove from one location in California 120 miles away to a destination. And that semi-truck carried Budweiser beer. Not that that's part of the story. What was really interesting about that semi-truck is that it was driverless. It had no driver, right? And it drove from one location on a highway to another city 120 miles away, and the driver was literally in the back seat. And what conditional statements allow us to do are say something like, if there's an obstacle in the way, slow down or stop. If there's an obstacle in the way, turn left or turn right. Conditional statements are those ifs. If there's rain, slow down. If there's pedestrians, stop. So conditional statements allow for things to be smart. And I just think that's a really cool example because that's a real world example of programming at its finest. I mean, in its latest form, we've got programming in cars that drive themselves. And so that's pretty cool. You know, a program might say, if number of pedestrians, help me spell that, if number of pedestrians, I might have got that right or wrong, if the number of pedestrians is greater than 0, stop. You know, and it's obviously much more complex than this, but you get how this can make our programs smart. If the number of students is greater than 24, open a new section of the class. If your alarm clock goes off, get out of bed. That would be the smart thing to do, right? If your alarm clock goes off, wake up. That would be the smart thing to do. You could have an else if, right? And we'll get into that. Else if you hit snooze, get up in 7 minutes and things like that. But so that's why we use conditional statements. As human beings, I kind of use that alarm clock example. As human beings, we make decisions based on conditions. So I'm going to even write that down because as human beings, we make decisions based on conditions. The if statement allows, there's no comma there. The if statement allows our programs to do the same thing. So as a human being, my alarm clock went off at 6 o'clock this morning. Under the condition I wanted to earn a paycheck today, that's the condition, right? Or you could say, you know, I wanted to educate. The condition is I wanted to educate my students, right? That's the condition. If that's true, if I want to earn a paycheck or if I want to educate my students, then I get up, right? So I make a decision to get up out of bed, take a shower, and go to work based on the condition of earning a paycheck and educating my students, right? So as human beings, we make decisions based on conditions, and we can translate that into our programs. We say if
bank balance equals or is less than 0.
If bank balance equals, well, how about that? Is less than or equal to 0.
What's greater than?
If bank balance is less than or equal to 0, go to work. And that's an if statement in its simplest form, right? So let's actually put this in some script and let's code this and just do a demonstration here. So let's just code this one for fun because it's a real world example, and we're going to say, hey, if my bank balance is 0 or less, I got to go to work. Otherwise, for whatever reason, I'm going to decide not to go to work, right? So I'm going to have an input type of text. Text money. And let's write a little script here. Function, I'm just going to call this fun. I'll create a variable called money equal to okay, and because I want to make sure it's a number and it's not a string, I'm going to do a parse float as I'm pulling the data out of the text box. I'm going to wrap it in a parse float to make sure that money is a number. And I could say if the money is less than or equal to 0, I'll just put a little h1 in here that's empty. Document.get elements by name h1, the first h1 on the page, dot enter HTML equals you're broke, better get up and go to work. That's how to stop being broke. Yeah, what are you saying? Yes, get element by tag name. I did that too fast. Let's do that again. Dot get elements by tag name, not by name. We talked about the difference between the two already. Okay, so this grabs the H1, the first H1 on the page, which is this one. If the money is less than or equal to 0, you're broke, better get up and go to work. That's how you cure being broke. Now, obviously, we have to call that function. I'll go ahead and put an input type of button. On click, we're going to call fun. And its value is going to say click me. Okay, so you can see that worked. If I put any other number in here, though, what happens? If I put any other number, money is not less than or equal to 0. So you can see we're changing the flow of our program. This statement will never run if money is greater than 0. Okay, so one thing that is worth noting here is that there doesn't have to be an else statement. An if statement can exist by itself. If the condition is true, here's your condition right here. Everyone look at the screen right now, please, and realize this is your condition. This is what you're evaluating. What I have highlighted here is going to evaluate to true or false. If it evaluates to true, everything in these curly braces, see where the curly braces start and end. If it's true, what happens in the curly braces will execute. That's an if statement by itself. It doesn't have to be more complex. You do not have to have an else statement. This is an if statement by itself. Okay? Now, does it get more complex than this? Absolutely. And that's, someone might say, well, what if you do have more money? Right? Else.
What if you wanted it to be like if you have less than?
We'll get there. We'll get there. We'll get there. So right now, if you have no money or less than no money, you're broke, better get up and go to work. Else, I'm going to copy this. Otherwise, the inner HTML is going to say, you have some money, but it's probably safe to say you should still go to work. So now there's two conditions. Either you're broke, better get up and go to work, or you have some money, but it's probably safe to say you should still go to work. Unless you're a multimillionaire, ready to retire.
I think we need like an else if for that.
We're gonna make it more complex. So here's the two scenarios. Less than or equal to 0. We say one thing. The else block. Now here's what I want you to remember about the else block. The else block is the false block. The else block, when it's by itself, is always false. So this would become the true block. The else block would become the false block. That's in a simple if-else. Now, even when it gets more complex, if you have an else by itself, it's always the false block. So if we run this, if we have a negative dollar amount, it says you're broke, better get up and go to work. If I put in anything that's positive, well, you have some money, but it's probably safe, you should still go to work. Okay, those are your two scenarios, one or the other here. Okay, so I paused the video there, and they said, well, what about more complex scenarios? Was a question that kind of came up there. So if you have no money or if you're in debt, it says one thing. But what if you have $10 million? You might not have to go to work anymore. So in our scenario, there's three cases. There's three possible outcomes. Either you're broke because you have no money or less than money. You're going to have some money, and some money is going to be between 0 and $5 million. We're going to consider that some money. And then otherwise, if you have more than $5 million, we're going to say you can retire. Because that's going to be your retirement goals, to have $5 million at the end. Okay? So since there's three outcomes, it changes this a little bit. We evaluate if the money is less than 0. That's one scenario. Else if money is less than $5 million. Notice I don't put commas in there. Don't put commas in there. So first we evaluate if the money is negative or 0. If that's not true, then we evaluate if the money is less than 5 million. And if the money is less than 5 million, I'm going to copy and paste this and say, good work. You're closing in on retirement.
So if you've got $1, you're closing in on retirement.
If you have $1 saved towards retirement, you're closing in. Specifically compared to the person that has $0. Right? Else, now we can retire. Because this else block is the false block, meaning that's not true, then this is going to execute. The else becomes the false block. Else, congrats, you can retire. The question was asked, how many else ifs can you do? There's not a limit. There's not a limit.
So you can continue.
Each one of these is a scenario, right? And in the real world, there could be 5 scenario outcomes. There could be 100 scenario outcomes. Okay? But realize in this, only because this is called an if-else-if block of code. This is all one block. Only one of these outcomes is going to execute. You're not going to get multiple of these outcomes to execute. It's just one. Okay? So I saved my file. Let me go ahead and refresh the page. Okay, so if I say 0, you're broke, better get up and go to work. If you say 1, good work, you're closing in on retirement. all the way up to 4,999,999. I think that's right.
Yeah.
$4,999,999. It still says, good work, you're closing in on retirement. That's the range that we set up in our statements. If I change this to $5 million, 5, 1, 2, 3, 1, 2, 3. Congrats, you can retire. And then, of course, if you change this to be anything greater than that, congrats, you can retire. So again, loops make your program powerful. Conditional statements, like the if statement, make your program smart. Let's look at another scenario. We could have nested if statements. Okay, so let's just look at our first if statement. If money is less than or equal to 0, it says you're broke, better get up and go to work. What if you're really broke? What if the money is less than 0? Or no, let's consider something else besides the money. If the money is less, if you have less than no money,
You can put debt.
I'm going to say, and you have a job. Check this out. If you have no money, I'm going inside the if statement here. Look at where the curly braces are. I'm going inside here. And if job double equals true, and you have a job. Okay, now I'm going to have to make a job variable. We don't have a job variable right now. And the job equals true, then you're broke, better get up and go to work. So let's put in our curly braces here. Now we have a nested if statement. Look at this. If the money is less than 0, you go inside. That's true. If the job is true, you're broke, better get up and go to work. Now look at that closing curly brace here. I'm going to put an else, meaning you have no money, and this means you don't have a job. I'm going to say, let's look for a job. Better search for a job quick. Okay, now you could make a control for the user to put in whether they have a job, maybe a radio button, true or false. For simplicity, I'm just going to say var job equals true. Take a look at this second if statement right here. You see the double equal sign? Everyone, look at your eyes to the screen. Look at here, var job equals true versus job double equals true. What's the difference between the single equal sign and the double equal sign?
Variable. It says this is true.
Yes.
And then the double equal sign says this is equal to true.
Okay, so you're close, but here's the difference between a single and a double equal sign. A single equal sign is the assignment operator. So in this case, you're assigning true equal to job. You're making that the case. Huh? A signal or something. A single equal sign is the assignment operator.
Spell the sign wrong too. We're going into it.
I wasn't trying to.
Well, in Microsoft Word, you get the red squigglies. They give you help. I don't have the red squigglies here, okay?
There's an N before the N.
Yeah.
Thank you. Assignment operator. This assigns the value. The double equal sign tests a condition. So this asks, does job equal true? It's a question. And it's going to evaluate to true or false. In this case, job is true. Does job equal true? That's the question mark. You would say yes. But if job was false, does job equal true now?
No.
No, it doesn't. In which case, when it doesn't equal true, what would run?
Else.
The else would run. The else would run.
So why does it? So what's the purpose of testing it?
Well, the purpose of testing it allows us to make these scenarios. The outer if says, okay, how much money do you have? If you have less than no money, then you go inside. Look at those curly braces, how big that is inside of that if statement.
Okay.
Once we're in the if statement, now we're testing to see if you have a job. We already know you don't have money. Now we're testing to see if you have a job. If you have a job, so here's the scenario. If you don't have money but you have a job, we're going to tell them better go to work. However, if you don't have money and you don't have a job, we're going to tell them better get a job.
Oh, I get it. So it tests to find.
It tests to determine what your output's going to be. Okay? Now let's run this, and I want to demonstrate this running. So right now, as it stands, we set the job to false. Okay? If we say we don't have money and the job is false, it says you better get a job. Right? But if we change this and we set the job equal to true, it's going to run this block instead. Now the job is true and we don't have money. It says go to work.
So is there a place that people can change that true?
Well, we could make a place in the HTML, maybe a radio button, and you would say if the radio button is yes, I have a job, then set the variable equal to true.
Oh, okay. So
Yeah.
that's just us changing it.
This is just us changing the variable manually because it's a little bit shorter.
Okay.
You know? Nathan?
So, what's the difference between the double equals and triple equals?
Okay. So a single equal sign is the assignment operator. The double tests a condition. The question was, what's the difference between the triple? And I'll just put this here, just for notes. The triple equal sign tests for the data type and the data to be equal. Okay? In other words, a double equal sign, you could have a string 5 and an integer 5. Those are different data types. However, they would evaluate to true because a string 5 does technically equal 5. A triple equals is going to test your data type and the data. Yes?
Do you actually care that much about grammar errors?
The question is, do I care about grammar errors?
No.
Unless the grading rubric says otherwise. Okay? And it depends on the scenario. Are you putting grammar errors? Oh, you're showing it in here?
Yeah.
No, I don't care. Forgive me for my grammar errors.
Okay.
I'm not doing this in Microsoft Word. I'm doing it in brackets, and I'm trying to go quick. Okay? All right. That's my excuse. All right. All of that covers a whole lot of slides. We talked about the if-else. You can see here that in their example, they assign the variable today equal to Tuesday. And if today is Monday, it says today's Monday, this output would say today's not Monday. Simple enough. Any questions on this here?
Yeah. So repeat that.
Yeah. I'll repeat this is the question. So we have a variable, and we set the variable equal to the word Tuesday. We then test that variable to see if it's equal to Monday. Well, Tuesday does not equal Monday. That's simple enough. So since this is false, the if block doesn't run. The else block will run. And
if today was equal to Monday, then it would say today is Monday.
That is correct.
Okay, so I get it.
Yep. Phil?
All right. The equal signs. What's the difference between the 1 and the 3 next one?
Okay, so the single is the assignment operator. It's okay. It's okay. The single assigns it. So it says today is Tuesday. It sets it equal to Tuesday. The triple equal sign says it's asking a question. Is today Monday? Is what this essentially asks. And not only is today Monday, but is the data also in a string? So the triple is also testing for a data type. Okay, so it's testing for the data and the data type. Either way, it's false. The data is not the same, so it's false.
So could you use a double equal sign in that if statement and it would still work just fine?
Yes. In this scenario, you could use a double equal sign and it would evaluate the same way. Yeah, double equal sign would work the same way here. Yes.
Is there a limit to the amount of nested if statements?
No. Nope. There's no limit to the amount of nested if statements that I've ever found. I'll put that caveat in there. That I've ever found. Okay? They talk about nesting it. We did that demonstration. Here you could see where they did a nested if statement. Both this statement and this statement have to be true for this write method to ever execute. Nathan?
Could you write that in one thing? Like,
On this scenario, you could write this in one compounded statement. Yes, you could.
So, how did you show how you did it?
Yeah, let me show how to do the compounding statements. Now, back in my example, there's complex output, meaning there's many scenarios. And when you have so many different scenarios, you cannot always write it in one if statement. But in our example on the PowerPoint, there's really only one scenario output here. So when there's less scenario outputs, it's easier to write them in compounding if statements. So in this case, it's asking for sales total greater than 50 and less than 100. So we would write that. Let me go ahead and I'll just go below here. I'll say var sales total equal to 75, just like they did on there. And say if sales total is greater than 50. Here's the compound. You have a double ampersand. That says and. So both of these statements have to be true. And sales total less than 100. Alert, good price. If you notice here, I'm always putting curly braces around my if statement. For right now, the book will tell you the difference. I'll go ahead and tell you the difference too. It's not mandatory when you only have one statement inside of your if. So since we only have one statement, I don't need these curly braces. It will work the exact same way. Matter of fact, a lot of languages, they even compound it even more. They compress it even more. They put it all on one line. In some languages that try and be, they try and compress the amount of code that you write. But it's good practice to put the curly braces regardless, even if you've got one statement or 30 statements. So if we execute this, really doesn't matter. You can see it's a good price. So I just condensed the two if statements into one. It all depends on the number of output scenarios that you need. And wow, it apparently thinks I can retire. I'm curious to see why. I guess when it's an undefined value, that's the output that you get because our variable is undefined. Let's go back to the PowerPoint. Let's see, compact version of nested if-else statements. Combine an else statement with a nested if statement. The ternary operator that we did last chapter is what they're referring to, is the compact version of an if-else statement where you had a something to evaluate followed by a question mark. then the true statement followed by a colon followed by the false statement. Gives you some benefits in that it's less to type and it's easier to read. Oh, here's another scenario where a nested if-else could be written simply as an if-else. And actually that's probably what they were referring to here, is that you can write these in different ways. Some are more condensed than others.
Is there any reason to use 3 equal signs as opposed to 2?
Only if the data type really matters. That's really up to you as the programmer. Does the data type really matter? We're going to get to the point, and I think you might have done this in your homework, where we're using if-elses to attach our event listeners. Like right now, everything in the example I'm just doing on click. But we did talk about in the last chapter the different ways to attach event handlers. And we talked about this particular method with the add event listener being the most not compatible, but what's the word I'm looking for? Flexible. Because you can attach an event and then later detach it. But not all browsers can support add event listener. So essentially, this is a way to see if your browser will allow you to add an event listener in this method. If not, we use the attach event method of doing the same thing. Either way, you call the same function, which is submit form, on click. But this allows you to do it in a backward compatible way. You test for a condition. If it doesn't support it by the browser, you attach the event a different way. And we just came back from a break, so getting back into this is the discussion of the switch statement. And so let me kind of discuss what the switch statement is used for. I'm going to delete my script so far. So we just have an empty function. And I'm going to ask for someone's age.
24, 21.
Okay. Since they're just telling me numbers, instead of reading it from a text box, I'll just plug it in, right? The age is 24. And like I said, if the age is 20, alert,
You're too young.
you're too young. Whoops, semicolon. Else if age equals 21. What am I saying?
You're okay. Yeah.
Else if age is 22.
You're okay.
I guess I'm glad I didn't hear that one.
No, he just said come here.
If age is 22,
You have a ugly.
I'm just going to put a question mark because you guys aren't helping me here. Else if
Shut up.
age is 20, I was going to skip to 24. I'm going to alert mid-20s. So as I refresh this, you can see that's the result, mid-20s. If I change it to a different value, you can kind of see a simple if, else if, else if, else if, else if. The purpose of a switch is to replace this with something a little bit simpler. So that wasn't extremely hard to write, but as they get more complex, okay, as your if, else if, else if, else if, else statements become more complex, there's a simpler structure called the switch statement where you can switch on the person's age. And in case of 20, we can alert you're too young. For the case of 21, you're of age, and just as for drinking, obviously. Case 22. And so you can look at the switch statement and say, okay, this is a little bit easier to type. It's a little bit easier to read. Okay, it's just slightly easier. Now, you could see here, if this runs, all this does is replace an if, else if statement. Greg?
So would you use the break once you hit 20?
Did you see what the question is, would you use a break? Well, it says you're too young, then it says you're of age, then it says you're old enough. The way to fix that is exactly what you were saying. Use the keyword break. The keyword break is going to stop it from what's called falling through. So it won't do each one, it'll just do the one. Now it says you're too young, and then you're done. So that's why you would add the break. The default is like your else block. Remember I said the else block is the false block. So as if none of these were true, you would run the default. Alert, I don't know how old you are. And so if I set the age to 33, since none of the cases are 33, it's going to run the default. But if I set it to anything else, 50, 100, it'll run the default. There it is. I don't know how old you are. And if you set it again to something else that's not one of the case statements,
You made it a case statement.
but this is a case statement, so it'll run the case statement.
Why are you setting an age?
I'm just manually setting it instead of getting it out of the text box to simplify the example. Okay. Now here, that's the benefit of the switch, is that it's a little bit easier to read and a little bit easier to work with. The downfall is, number one, you have to learn how to work with it, right? That's a downfall, is that it takes a minute to understand it. The second downfall is that there's no ranges here. You have to put in every single value. Otherwise, before I could say if the money is less than $1 million, that's 999. Well, that's 1 million different numbers, right? So switches are not good for ranges. They're just good for 5 or 6 numbers, or maybe 5 or 6 letters. You could use letters, 5 or 6 values, but not ranges. It's not good to say if the age is greater than 100. No range values. Okay? So in this case, the output here, we have a document.write. The city location function, you're calling the function city location, passing it Boston. And we're switching on, if you look here, Boston is the text. It gets stored in American City. It gets stored in American City. Then we do a switch on American City. For the case of Boston, that is the scenario. It'll return Massachusetts. So this document.write would write Massachusetts in a paragraph. Would be the output of this. And that brings us to the end of our objectives, where we talked about working with arrays in the last video. We worked with loops in the last video. This video we worked with if and if-else statements and switches, the keyword breaks, and the end of the PowerPoint. 45 minutes on this video.